Hi class, I'm going to start with number 2 from that list of 4 problems that I gave you the other day. The first thing that I would do is I would write down at the bottom the equation that I'm trying to get to, and that's usually the one that's given first, but that's the equation that I'm trying to sum everything up to. So I'm trying to get 1, 2, and 3 to be this final equation. So the first thing I do is I will look for a product or a reactant that's significant. So in this case, my reactant H2SO4 is really a main component here. So when I look at my list of equations, I see H2SO4 is on the product side in the first equation. So the first thing that I would do is I would flip that equation around, and I would make that equation look like this. H2SO4 liquid goes to H2S gas plus 2O2 gas, and what I have to do now is I have to change the sign of the delta H since I flipped the reaction around. So it would look like that. So now this equation up here I don't use anymore. I would just run a line through it. So now I'm going to see what else I might have to do. So the next thing that is important to note is that anything that occurs on the product side in one equation and on the reactant side in another equation gets canceled out. So H2S from that gets canceled out with H2S from this. Then the other thing that I see is the 2O2, and the coefficients have to be the same. That cancels from product side to reactant side. And then there's one other thing that would be I would be able to cancel out, which would be H2O liquid on this side of the equation in this one, and H2O liquid on this side here. So now, having done that, I'm going to go back and I'm going to highlight the things that I did not cancel out. So H2SO4, SO3 gas, and H2O gas. So if I bring those components down, those components are my final equation. So I've completed this one, and so now I know that the delta H for the summed up equation is this, plus this, and the value that I get when I do that is 72.5 kilojoules. All right, very good. That's number 2. Then I'll take a look at number 3. So number 3, if I have it, I want to make sure I have it lined up straight. Yes. Okay, so number 3 is this reaction. And so I took the reaction that I'm trying to get to, which is the one that I've listed here at the bottom. Again, on your worksheet, it's the one that occurs first, but that's what I'm trying to work towards. So let's look at what is something significant here. So one of the first things I notice is that the only place I have N2 is in this first equation here, and it's in my final equation. So I know that that reaction is going to have to go in that same direction because that's the side of the equation that it's on. And then the other thing I notice that is significant is that this equation here has 2NO2 on the product, and here it is in my final. So I'm pretty sure that reaction isn't going to change at all either. But then I go down here, and I see that I have H2O here, liquid, on this side, and I have it on the reactant side in this equation. So I probably have to get rid of it. I do have to get rid of it because it doesn't occur in my final equation. So the first thing I'm going to have to do is I'm going to flip this equation around. And so it's going to become H2 gas plus 1/2 O2 gas. And we haven't used fractions to balance equations much, but it's possible to do that. It works the same way. It's just a half of a coefficient. And that becomes H2O liquid. So now, right now, my delta H becomes positive 43.7 kilojoules. But here's, so this reaction I'll get rid of, just like I did in that last example, because I'm not going to use it anymore. But now there's a problem, because although H2O doesn't occur here, it occurs here as a reactant, here as a product. But there's 4 here and only 1 here. So what I have to do is I have to multiply this whole equation through by 4, including the delta H. So this now becomes 4H2. It becomes 2O2, because 4 times 1/2 is 4 halves, which is 2. And it becomes 4H2O. And then I have to multiply that value by 4 also. So now it looks like I'm in pretty good shape to get rid of the components that will not appear in my final equation. So I'm going to cross out the 2 NH3s. I'm going to cross out the 4 H2Os. I'm going to also get rid of, all right, here's an interesting occurrence. I have 4 H2s here, I have 3 H2s here, and 7 H2s on this side. So the 4 H2Os that are here, I'm sorry, the 4 H2s that are here, plus the 3 here, that makes 7. So these will all cancel out with this, okay? So now the only thing that's left is this N2, which I pull down here, okay? And then 2 O2s, which I pull down here. And then the only other thing that's left is that 2 NO2. So I've finished. And so what I have to do is now I have to take and I have to add up a negative, I'll do it on my calculator here, negative 115 plus a negative 142.5 plus, I'm going to put in brackets 4 times 43.7, and I get as my answer negative 82.7 kilojoules. So that's it. I hope those were helpful.